everybody, Zane here, back with another video. For this one I'm going to do something I think a lot of you will find useful, and that is some useful functions in C++ that will definitely be handy in your toolkit, so let's just jump right into it. Let's first include the IOStream library. This is by default, so we can use some methods. We'll start off our int main function, and let's declare a string variable, and let's call this greeting. I'm going to set this to hi, me, Zane. Cool. Let's first print this out, make sure nothing's going wrong. So we'll just do standard cout, greeting, and we'll do a end line as well, so it's clean. Cool. So this is just our basic string here. Now what if we wanted to add stuff to our string? Well, we can kind of use the same concept as numbers, where, you know, if we want to add like 1 to a number, we could just do number equals number plus 1, or number plus equals 1, or since we're using a 1, we just do number plus plus. Now I know, I'm pretty sure this is just for C++ or maybe even Java, but yeah, I'm kind of going on a tangent here, but we can kind of do the same concept with greetings. So if we did something like greeting, I meant strings, not greetings. We just have a called greeting here. If we did greeting plus equals, and we did something like period space nice to meet you. Ended that off. And now if we print this again, I'm just going to copy this here. And also, I'm going to keep printing out our newly made greeting so we could keep seeing the changes that were made. Anyway, let's print this out. And you'll see that this was added just with the simple plus equals. I think that's definitely handy. Another way you could add is do greeting.append. And you can add whatever you want to add to it. So we'll do like a space meow. And let's also print that. And you'll see right at the end that you're printing that. So these two are kind of the same thing, but still good to know. Next thing, we're going to go into how to insert stuff. So we can do greeting.insert, open up these brackets, add a semicolon, and in these brackets, the first argument is going to be the starting index, and the second argument is going to be what we want to insert. So let's say I want to insert maybe another period here. What we could do is, if we count up till here, I know for a fact that this is 10 indexes. So if I put 10 as our first argument, and then let's insert this with a question mark instead, so we can easily see it. So I'm telling it at this index, insert this. Now let's print this. And you'll see that a question mark was inserted at that 10th index. Now what if we want to erase? Well, we can kind of use the same concept. We'll do greeting.erase. The first argument is again going to be the index that we want to start at, or in this case the index that we want to erase, and that will be 11 in this case. Sorry, I'm losing my voice. I use 11 here because I want to remove this period. So what I'll do is tell it I want it to be start erasing at the 11th index, and the next argument is going to be the number of elements we want to go to remove. And what I mean by that is, if we wanted to remove just the period and we're at index 11, we would just put 1. But if we wanted to remove the period and the space, we would put 2. If we want to remove the period, the space, and this n, then we put 3, etc. So if I put just the 1 here, add the semicolon, print this out, run it, and you'll see now that the period is gone. Alright. Another way we could remove is, I think one that a lot of languages have, and that is the popback method. So if we do greeting.popback, and we just open up and close the brackets and add the semicolon, you'll notice that this just removes the last element. So I think this is pretty useful too, or if you want a quick and dirty way of just removing the last element of something, just use popback. You don't have to specify any indexes. Alright, next one. This one's a pretty useful one, and I use this constantly, and that is the find method. So if we do greeting.find, and we specify what we want to find, so in quotes, I'll put meow. What this is going to do is this line of code will return a number, and this number is going to be the first index of the value that we passed in. So it's going to give us this index here, the one right before the m. So this again will be returning a number. So what we could do is we can actually assign this a variable. So we'll just say int n equals this number. So now n is equal to the first index of meow. And now I can use this with the other function, which is a replace. So if I do greeting.replace, and for replace, it's going to first ask me, where do you want to start? And that's going to be the starting index of whatever you want to replace. And since find already gave us that starting index, and we created a variable for it, we can just put in n. Next variable or next argument is going to be how many slots do you want to go, or how many from n do you want to move to the right. And I'm just going to go with 4, because what I want to do is I want to replace meow with woof. So the third argument is, as you may have guessed, what we want to replace with. So I'm going to put woof. And now if I put the print thing, yes, we'll see now that meow has become or replaced with woof. Cool. Next thing, let's do substrings. So a substring, I'll give you an example. If you have the word race car, a substring of race car could be race, it could be car, could be ace, could be any variation as long as it's from the original string. So this could be very useful as well. I can't really think of any ideas right off the top of my head. I think of data science where you might be looking for perhaps a specific customer ID or a identifier of a customer ID that you want to remove or extract. But regardless, substrings are very useful. So what you could do is greeting.substr, not substring, substr. And in the first argument, you will pass in, kind of similar to our replace here, the index of where it starts. So we'll just pass in n again because we're kind of doing the same thing here. And I want to go 4 slots. So this here is going to give me a string value. It's going to return a string value. So what we could do is we can just give this a variable by itself. So standard string s equals this string. So now s is this substring. Maybe I'll do ss for substring. And now if I was to do standard cout to print this substring, we'll add a m line. Let's see what it says. We just get woof. So we got a substring from our initial string. Now you might be thinking, hey, wait, I thought we did find on meow. That's true, but we also did it on this specific index at this specific slots, and we replaced it with woof. So if we actually took this out and reran it, this will go back to meow. Anyway, let's get back to woof. Cool, so we got our substring. Next thing, and kind of the last thing, is going to be find first of. So this one is very useful when we're trying to find whether or not a list of values or a list of characters is inside of our greeting. So what I mean by that is if we did greeting.find first of, we passed in things like a, e, I, o, u, this will find an index for one of the values. Or maybe a better way is it finds the first occurrence of one of the characters that we passed in here. So it finds the first occurrence of one of the characters. Now if this was empty, then there would be no characters, and so there's no occurrences, and it will just return the end position. And that's another topic for another day, but what this will do is it will again find the first occurrence of one of the characters in it. So if we passed this into its own variable, let's just call it int z, and let's print out z. So this gives us 1. So this is telling us that one of these characters has appeared in our greeting. Now what if we did something like x? Now I know and we know that x does not appear here at all. So if we were to run this, now we see -1. So this could again be useful, or if you were doing something like, let's see, if we did like if greeting.find first of, and we're trying to look for a bunch of characters like this, right? If this is equal to -1, we could print out something like, oops, none of these characters were found in the string. So this would be something that would be useful if you were to look for a certain list of characters. but I think I'm kind of going on a tangent here because this gets a little more complicated and I'm using it in a very basic form. But yeah, so this is what we just did for some string stuff. I'll go over very quickly some vector stuff. So let me remove some of this. And since we're going to be using vectors, I'm going to include vector. And I'm also going to include algorithm. Because this is another one of the libraries that I personally use a lot, and I think you guys should as well. Depending on obviously what you're doing. But anyway, so let's just say we have a standard vector. It's of type int. And we'll call this array. And we'll set it equal to 1, 2, 3, 4, 5, 6. Sure. Let's run this, make sure nothing's going on. Cool. Alright. So what if you wanted to find something in our array? What we could do is we could use our standard find. And this is different than our greeting, because before we were doing greeting.find, blah blah blah. But here we're not doing that. We're using our actual method. And this is coming from the algorithm library. So very important. Standard find. Our first parameter is going to be the array.begin. Second parameter or argument is going to be array.end. And thirdly is going to be what are we finding? What are we looking for? Let's just say we're looking for the number 6. Now when we run this, nothing's going to happen because this is just returning an iterator value. An iterator value is very, not really subtle, but it's kind of more of an advanced topic, or maybe even intermediate, but I'm still a noob, so I think it's advanced. But this right here doesn't necessarily return yes or no or something like that, but it actually returns an iterator value. And if we were to say, if the standard find of this, and maybe we can put this in brackets as well, if that does not equal the end of the array, that means, and just bear with me, okay, alright, some errors here, give me 1 sec, let's try that, cool. Alright, so we are looking for the number 6. It looks like we found it. Let's say we remove this. 6. Let's try running it. Not found. Cool. It's working. But why is it working? Or how is it working? So what we're doing here. First, we are finding this value. This again will return an iterator number. And then if that does not equal the end of the array, then it has been found. So I know that's kind of like a weird thing to kind of understand, where you're looking for something, but if it doesn't equal the end, then it's been found. Well, it's kind of just something that I've been drilling into my own head here. But if we look for that value, and that does not equal the end, then it's been found. Otherwise, it's not been found. I hope that made sense, because I know for me that was a little bit of a struggle. But I think what I'm going to do is I'll add some examples in my description below to kind of help out with this, because I know that this could definitely be something that is a little bit more on the subtle side. I feel like I use subtle a lot. Anyway, I think I'm going to end it up here. If you guys have any questions, comments, feedback, please let me know in the comments below. Otherwise, hit that like and subscribe button, show me some love, and I'll see you in the next one. Peace.